So, okay. So, okay, well, it's a short video of how we could do the refactoring. Remember that the idea is that it's reading a file. So there you can see there is repeated code is breaking the line separated by columns. So I do a struct to local, and it creates a record instance variable, but here it has a problem. It's not creating it in the right context. So, I will create it as an instance variable. That's not a refactoring. So after doing that, I check that everything keeps running. I don't know why it's okay. So now we can see that is customer data is record. So I do an inline temporary, and it replaces customer data with record. The same with address data. I'm going to do an inline to replace that instance. That variable doesn't make any sense anymore. So now everything is related to record. Everything keeps working. So now I'm going to start doing some semantics to these collaborations. The first one is if the record is a customer record, so I do a struct method for that. Then struct method for that, import customer record. Then struct method for that is address record. And import address record. Okay, so now we have that thing that told you that it was different. It was like in Java. So this change is not a refactoring. What I'm going to do, I'm going to use the correct semantics of the streams. So I'm going to ask stream at n is while false, and remove the line below that was repeated. So that was not a refactoring, so I have to be sure I didn't make a mistake. And now I'm gonna do more struct method. Create record. Well, create record. And those two as one import record. So, that's a little bit more understandable, I guess. And the nice thing about it is that now we have like a template method here. This is a template method. So, because if it is a template method, we could subclass customer importer, we can create a abstract class with this method, and then subclass and use it as a white box framework. That's one possibility to other importers. Or we could also create black box framework. Let me show you how verifying each of these pieces. If we create an object to represent a customer record, and then another one to represent how to import an address record, we could have, a kind of black box framework where you create the importer with those record types and, make it more reusable. So anyway, that's how it ends up being. Okay, so any comments? Cool? No comments?
Yeah, I have a question.
Yeah.
So this methodology, what is it?
The idea is if you have a method with you create an object from the method, and the idea is to have all the local variables to be instance variables and to
be able to extract all the, semantics from that long methods and give it more, kind of semantics and make it more discrete. That's right. And make it more easy to read,
But there is not
No. No. It's an idea. It's a pattern. Yeah. Yeah.
Yeah, the one thing that you said was not a refactor.
Yeah.
I would almost claim it is a refactor because you're doing behavior-disturbing transformation and you're kind of switching.
Yeah, you're right. It's not an automatic refactor. Automatic. That's right. You're right.
It was a refactor because you were just changing the way you did the iteration
Yeah.
from the Java way to the right.
Yeah, that's true. Yeah. It's correct. Yeah.
Manual refactor.
That's right. It's a manual refactoring. Okay, so now, yes, I'm going to start with my talk. Oh.
You can see it in reverse.
That was not the idea. So, when I thought about this talk, I thought about public, and the talk is for people that don't know Smalltalk very well, okay? So, it may be kind of boring for other people, but the idea is to show how easy it is in Smalltalk to create your own kind of syntax, and why it's not that easy in other languages. So, first of all, what is syntax? I look a lot of definitions, and as always, it's very difficult to find a good one, but I got this one. Syntax is a set of rules, principles, and processes that govern the structure of sentences in a given language. So grammar is also a set of structural rules. It's a set of rules, but the idea of grammar is that to govern the composition of clauses, phrases, and words in a given natural language. Yeah? I don't know if the difference is easy to understand, but thinking it from the point of view of change, one question could be, how easy is to change the syntax of a language, and how easy is to change the grammar of a language? And changing the grammar of a language is very easy. We do it all the time when we make jokes. We change the distribution of the words, or when we make poetry. Poetry is, playing with the grammar. But the syntax is not so easy to change. We cannot change what a dot means in a natural language, what a semicolon means in a natural language. We cannot change how a word is written. Yeah, it's very difficult to change the syntax. Okay, complexity. We all know that the complexity we have when we create system is the sum of the essential complexity and the accidental complexity. The essential complexity is the complexity of the model, of the domain that we're trying to model. And that's very difficult to reduce, because if we want to reduce complexity, we have to reduce both of them, but we cannot reduce essential complexity. So if you want to reduce complexity, you definitely have to reduce accidental complexity. And the accidental complexity is the complexity of the tools and the language that you're using to create the model, to create the system. So it's very important to have very small accidental complexity. And that's why Smalltalk fits very well. Because what's the Smalltalk complexity related to the syntax, for example? Well, as James mentioned yesterday, Alan Kay said once when he was at Park, they were in a meeting with Ted and Dan Ingalls, and he said, I accepted that you could define the most powerful language in the world in one page of code, and they say, put it or shut up. Okay, do it or don't say it, basically. And he said that because he knew Lisp. And yeah, Lisp, if you look at Lisp at the manual 1.5, you can see that Lisp is defined in one page. It's a meta-circular interpreter defining itself. So he said, okay, if Lisp can do it, I could do it too. But he also says, well, when he was in Sale at 1969, that's when he really understood Lisp. He said, no one had penetrated the mysteries of a val and apply, that are the circular functions of the Lisp interpreter. Everybody knew about cur, coulter, cons, those functions, but nobody understood how the language worked. and he realized that in the 69. And I mention this because if you read the History of Programming Languages, the second book, there's 3 books of History of Programming Languages. There were 3 conferences about it. The second one, there is where the early history of Smalltalk is the paper that Alan Kay wrote. And there is one about the evolution of Lisp written by Richard Gabriel and Guy Steele. And I was reading that and I was surprised to see that when the time for question and answers, the first question was from Alan Kay, and he asked to Steele and Gabriel, when and how did you realize how great Lisp is in the meta sense, the meta-circular stuff? And Guy Steele answers, I tried to read the Lisp 1.5 manual and discovered it was trying to define the language in terms of itself. It was just not at all well founded, so he thought it wasn't interesting and made no sense at all. A year later, I had this sudden conversion, decided on an implementation, and then understood what the real idea was. So I would say that it was about 1972 when I suddenly realized how it hung together. It was difficult to glean from the 1.5 manual. So what I'm trying to show here that the Lisp guys took more time to understand what Lisp really was, while Alan Kay did it, before and had more time to think about that. But it also says that there are so deep flaws in the logical foundation of Lisp. Not all of the things are functions. Some of them are called special forms. So that's the idea of simplicity comes from Lisp. What is a closure? I have to talk a little bit about closure. Closure is the union of the Lisp lambda functions and the algol 60 blocks and lexicographic binding. That's the idea of the closure. It is created with the scheme language. This is an example where you can see we can send the message factorial to 100. This is a closure where when you evaluate it, you don't get the result of factorial 100 factorial, but the object that represents that collaboration. And of course, if you want to evaluate it, you have to send it a message. It's an object that represents code. And of course, because it is an object, you can assign it to a variable, you can pass it as a parameter, you can return it and everything, like any other object. Hola. And, these guys, Guy Steele and Jerry Sussman, while they were discovering scheme and while they were creating scheme, they wrote, is it okay? Is it working fine? More or less. They wrote these 4 papers that are very interesting. The ultimate lambda, whatever. For example, the ultimate declarative, lambda, the ultimate imperative, lambda, the ultimate go-to, lambda, the ultimate opcode. They're very difficult papers to read, but the conclusion, I think is the most important one, is that when you have full closures, you can avoid control flow syntax. So, how's the syntax, Smalltalk syntax? We all know that it's object that receives a message and other stuff, not that important. So let's see if, okay? So if in basic languages like Java, algol, derived languages, the syntax is almost this one in every language. So if we want to convert this to an object-oriented language to Smalltalk, we know that, okay, the statement, that block, has to be represented by a closure. That's the idea. A closure is an object that represents code. But the problem is that doesn't compile because it doesn't follow the syntax. It's not object that receives a message. So what's the trick to make it compile? Flip it around, okay? Put the condition first, and the message will be if. So that's what Smalltalk does, okay? That's the idea of the if. And we can see it here. Yes, we have a condition. If true, evaluates that. But as we all know, if we try to debug this, and we want to get into the implementation of the if true, it won't work. Because this is really an illusion. It's not actually sending the message if true, it's inline by the compiler, whatever. But just to show that it's really implemented, I will send the message if true, and then we can see how it is implemented. So now we are in the implementation of if true for true, okay? That evaluates the closure that we send as a parameter.
Another way we need to take the block, put it into temporary, and then send it true without false. In that case, the compiler wants inline.
Okay.
Because it's not a block regardless.
Okay, cool. Okay. Okay. So, let's see other languages that play a little bit with the if. For example, in Ruby, you can write this. Why, I don't know. But, it's a language invented by a guy from Japan. So, he plays a lot with those things. And so you can say, do this if that condition is true. Also do that. So can we do this in Smalltalk? Well, yes, of course. It's pretty simple. We have it here, so let's do it. Of course, well, it's not implemented. I will implement it in block closure. Oops. And how should I implement it? Well, it's pretty simple. I return a condition if true self. So it's just, you can see it's very simple to create these kind of messages. So just think about this. How could you do this in Java or in C++ or in C#? There's no way. You cannot do it. Because if you want to do it, you have to change the syntax. And the syntax of the language is owned by Oracle in Java, Microsoft with C#, etc. But in Smalltalk, because the syntax is so small, this is not syntax, this is like grammar. And you can do it without any problem. Same idea with unless. Unless is like the if true, okay? Excuse me? Yeah.
Okay.
Do you feel fine? No, I don't feel fine. And if I run this one, it won't work. I mean, it will return nil. Thank you. So the same thing with unless. I can easily implement it. The same idea, block closure, and here, of course, is sorry. And now you have there, no? It's false. Yeah? And here it won't say anything. Oops. Well, I don't know what I did. So as you can see, it's pretty easy to do this stuff in Smalltalk. And let's take it a little bit further, because some people like the classic syntax. They want the if, and then the condition, and then... So can we do this? Okay, let's try something very, very weird. For example, this. If true, that condition, then evaluate that, else evaluate the other. So almost the same as C, almost the same, but for the true here. So can we implement this? Yeah, it is very simple. We can create a class called if, and then we can have a global object called if, that is an instance of the class, and then implement the message true, then else, that use the message if true is false. I mean, no small talker would ever do this, but, you know, I just want to... Except me. But, I mean, if you want to do it, it's pretty easy. You can do it. Okay? It's just to show the flexibility of Smalltalk. Okay. So, those are the things we implemented. What about the while? So, while, again, does not compile. So, we know the trick. We have to flip it around. And then we have the statements have to be a closure. What about the condition? Well, usually people say here, oh, the condition should be a Boolean, because they don't realize that the condition is evaluated on each loop of the while. Because in classic languages, they don't see it as a code, they see it as a condition. Okay, so it has to be a closure, and the idea is you have condition while true closure. So, example. I'm not going to do the while true example, but let's try to do a different one, a do while. That changes the thing. So, do this while this is true. Again, pretty easy to implement, but the implementation I'm going to do is not using the while true, but implementing it here by itself. So, self in this case is what you want to execute, and the block here, I'm going to call it condition, is the condition. So if the condition is true, then what I have to do is evaluate myself, and then I have to do again the loop. So what I'm going to do is a condition do while self. And self do while, thank you.
Evaluate a condition at the top.
What?
You have to evaluate it. Yes.
I did something wrong.
Yeah, the condition is condition value is true.
Condition value. Thank you. So there we have it. It's working, but what's the problem with this implementation? The problem with this implementation is that it's recursive, and you get, stuck a context for each loop. Well, anyway. So can we convert this recursive implementation to a tail recursive kind of language? Yeah, it's pretty easy. How to do this? How we do this context? Restart. I mean, if the debugger can do it, why can't we not? I mean, so we'll do this. And here we have it. Okay, so, and we're not using too many contexts. Okay, the same thing we can do another common syntax statement. Well, thank you. Another common, statement now in Pascal or other languages, repeat until. Well, it's also pretty easy to implement. As I'm not going to do it because I'm running out of time. And of course, the while true, as the if you like that.
No, this becomes an exercise.
That's right. That's an exercise for you. So exceptions. So we all know exceptions, again, basic Algol 60 kind of syntax languages, try, catch. We know that we have to flip this around to make it compile. We know that these are closures. And so we have this way of of handling errors. Undo, okay? So if I signal an error, and I catch it here, I say I want to handle errors, and then I will return by, in this case, okay? This is a handler, and this is the condition to handle the exception. But the question is, why is the condition always a class? I mean, because that's the condition for handling exception, but I'm not writing a condition. I'm just putting a class and writing a class. So there is an implicit condition that says internally, it verifies for the, if the instance of the exception is of that class. So why it has to be implicit? The problem with that is that it creates, and the people from ERCAP knows that, a big hierarchy of classes of exceptions that don't do anything. They don't do anything, they don't add value. We create exception classes because we want to differentiate when a customer is not found from when the supplier is not found, and what happens is you end up having 1,000 exception classes and nobody uses them. For example, let's see in Smalltalk, zero divide. How many times is used zero divide? Let's see. Reference to the class. Whoa, 31 places. But let's see how. Well, this is a test, this is a test, this is a test, this is a test, 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 test. Okay, here, not a test. But it's signaling the exception. It's not handling the exception. Here is signaling the exception, not handling the exception. Here, signaling the exception, signaling the exception, signaling, 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 test, 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 test. So, how many times is zero divide handled? Not even once. Zero. What about subscript out of bounds? Subscript out of bounds. Okay, here, signal the exception, test, signals the exception. Well, hey, we have one here. It tries to get the item from the list, and if it's outside the bounds, it does a row minimum with the size of the list. Yeah? I mean, if they do this from the start, it will work exactly the same. No need to do that. No need to handle the subscription out of bounds. Okay? So that's not a good example of handling exception. This one is a test. Signaling the exception is a test. So what I'm trying to say is we have so many exceptions sometimes that we never handle. So why are they created? And the issue is, there are two reasons, but one of the reasons is that every time we want to handle an exception, we have to put the class. And we don't know how the exception is going to be handled, so we create more classes than exception classes that we really need. Because we are preparing for the future, So my suggestion is a small suggestion, I don't know if it makes a lot of sense or not, is why don't we allow to put a condition, a real condition on the on, and not only a class. And it's pretty simple, just put a closure. So this on an error message text equals hello, so handle the exception. So how can we do this? Let's debug a little bit how the exceptions work. Here it's going to signal the exception. Here it signals the exception. Well, and here is when it looks for the handler. Doesn't matter. Here is the part that is important. Look at this. The context is getting the exception class. That's the parameter of the on, is error in this case, and then it sends the message handles to it. And this is implemented in exception, saying, okay, is the exception that's being thrown of the same type of me? So, if we want to put here a closure, what we need is for the closure to implement handles. So that's what we're gonna do. Sorry. We're going to implement handles in a way that is going to value itself sending the exception that received. So now if we evaluate this, we're going to get by. And, well, of course, I think you understood how it works. So this is a small change that I think it could, help a lot to reduce the amount of exception classes that sometimes we have. Again, think about this in Java or C#. It's impossible. No way. Well, I'm going to skip this.
Then it's hard to find references, for example.
Yeah, I mean, there are other problems. There are other problems because you have to, maybe you have to refine, the name or you can have objects and you will have to look for maybe a message, I don't know. But yeah, you can have other problems.
Makes sense to have a single class exception and class methods for each kind of exception that has sort of an instance.
That's right. I mean, yeah, of course. Yeah, you won't need that amount of classes. You will. That's right.
I use class instance method to test for the condition.
Yeah.
Like this.
Okay, so I'm running out of time.
More expensive than having an instance. So, no, the condition is, because you're not going to need that for class. Don't create. I think the lesson. Don't create classes for you. But classes are cheap.
Okay, just to end the talk, what's the problem with this code? Well, the problem is that if there is an exception between opening the file and closing it, the file won't be closed. So how you solve this? You put that in an ensure, you send an ensure message to be sure that always the file is going to be closed no matter how, this closure results. But if you do that, you have to do that all the time. Yeah, so you have repeated code. So how do you subtract this repeated code? Well, that's what Kembeck suggests in his book. Use it as, create a message like open during that opens the file and evaluates the closure while it is open and then close it. In Faro is open do or something like that, or detect do, I don't remember. So again, how do other languages do it? For example, Java, special syntax, try, where the output, the thing that you are putting here has to be closable, has to implement the interface closable. So again, they solve it as a syntax stuff. Well, and of course you can do more things. So what I wanted to show, what are the conclusions, is that when you have less syntax, you have more flexibility. Less syntax is more grammar. More grammar is easier to change, easier to augment your language. And what I like to think about, the way I like to think about this is that Smalltalk is not really a language. It's like an abstract class. And every time you download Smalltalk, you create your own Smalltalk. It's your own language. It's like Spanish. There is not really one Spanish. Spanish is like an abstract class, and you have the Spanish of Buenos Aires, the Spanish of Tucumán, the Spanish of Córdoba, Culiao. And, and each place has its own customizations of the language. So the same thing we can do it with Smalltalk and not with other languages. So don't be afraid, make your own language. So, I don't know if we have time for questions. I'm the timekeeper. I'm sorry. Go ahead. So, yeah. Oh, maybe one question if, I don't know. No questions?
Maintainability of the code, what do you think?
I don't think it's going to be a problem because, it's code like any other code. It shouldn't be a problem. You should do that if it's going to be more readable. That's the idea. If it's going to help. If not going to help, don't do it. Yeah.
I have a question. Have you tried this in working in a team, and how do you manage there in the code when you use your own syntax, you have to always provide.
Well, yeah, it's like the. Yeah, of course. I mean, there is no difference between doing it as a part of the language or doing it as a part of a system. You have to share what you did. I mean, it's the same thing, and it has to be a culture around it to understand what you did. I mean, there is no difference. That's the good thing. It's at the same meta level. There is no different. Why would it be a different? I mean.
Well, it's pretty common. If you think when we work in issues, for example, we end up speaking in English there because that's what everybody understands. So it's something to model. Everybody keeps using the default.
But there are always new words in every language. You create new words in English all the time, the same in Spanish. And so if the word is a good one, it gets spread out. It's the same thing here. It's the same idea. Okay. I don't know. He has to. Yeah. Okay. You come on. Yeah.